Hi, everyone, and welcome to our first lesson of pre-calculus. I got to apologize, we don't have something more exciting for you than lines. Fairly basic concept that hopefully we're all already pretty familiar with, but it's a pretty important concept in mathematics, and so we always have to take a day just to make sure everybody's on the same page and remember some of the basics of lines. So you can take a look here at some of the formulas for lines. Hopefully those all look familiar to you. If you haven't seen the triangle before, the triangle is delta. It means change. And one of the things to take note of is that slope is really an essential concept for lines, and it's kind of the defining feature of a line. A line has a constant rate of change. It has a constant slope. So if you look at a line and you look at any pair of points on that line, the slope between those points will be the same. It doesn't matter if I pick this pair of points or that pair of points. I could put another point here, and any pair of points I look at and find the slope between those points, it will be exactly the same if it's a line. So it makes a line a line. If you look at another type of function or graph, if I find the slope between those 2 points on that parabola, that'll be a negative slope. But if, say, I look at those 2 points, that'll be a positive slope. Or between those 2 points, that'll be about a slope of 0. A parabola has a changing slope, so does every other function. But a line has a constant rate of change. All right, so let's take a look at some problems here. Let's say we want to find the slope. That's the key thing for a line, and then write the equation of the line. So for some reason, we use the letter M for slope, probably French or Latin or Greek or something like that. I'm not sure why we use M for slope. But just make sure when you are doing a slope that you put your y's in the numerator on top. My first time teaching pre-calculus, I was so kind of annoyed by the fact that we had to do lines on the first day. I was all excited to teach advanced mathematics, and then realized, wait a minute, I'm starting with lines. What is this? That I just kind of didn't pay attention to what I was doing. I went too fast, and then wouldn't you know it, that meant that I messed it up. I put the x's on the top of the fraction, and felt kind of silly that I was doing slope wrong. But that's what happens when you think something's kind of maybe beneath you or too easy. You don't have to pay attention to it. Well, that's when you make silly mistakes. All right, so there's our slope. And then if we want to write the equation of a line, there are a few different methods. I'll show you 2 of them right now. One of them I like to use is that we start with a y equals mx plus b, and we know the slope, we know the m. So we've got this. And then we want to know what that b is. If we knew what the b is, we'd have the equation. So we're trying to find that, but there's 2 other variables here. Well, we know some x's and y's. So we can take an x and a y here and substitute them into the equation. So just pick one of the points, doesn't matter which one. Just do pick a point. You can pick an x here and a y there. Pick one pair. I'll pick this point, and you can substitute in the y and the x, and then just solve for your b. So you'll have 3/5 there. And then you could fraction bust if you want to, or you can just subtract that over. That's 5/5 right there. And so you'll get 2/5 is b. Just make sure you realize that's not the final answer. You did want the actual equation of the line. So you'd have to go back and actually rewrite it. So that's one way to find the equation of the line. This is the way that I'll typically use, but another common method is to use point slope form, because we have the situation a lot where we have the slope and a point for a line, and so they came up with a nice kind of plug and chug formula you can use for that situation. And so just make sure you realize you want to substitute the numbers into the x sub 1 and the y sub 1. Those are subscripts. We use them to number things. So just the first x, first y. So y minus 1 equals 1/5 x minus 3. And then, I mean, technically that is an equation of the line. And so if you ever were allowed to just write any old equation in any form, you could stop there. That does happen sometimes, but usually we'll want you to do the slope-intercept form, and so you would have to isolate y, get y by itself here. And so you'd want to distribute the 1/5 and then add the 1 over. Again, you could fraction bust if you really wanted to, and then at the end divide the 5 back over and to get y by itself if you really don't like fractions. But 1 is 5/5, so if you add that 5/5 over, then take a look at that. We get the same answer. Math works, regardless of the method you use. All right. So again, either method, whichever one you like better. I'm going to use method 1 from now on in my examples, but either way, perfectly fine as long as you can get the right answer. It is always nice to check. If you do 2 methods, you can check they match. Also, we use the point 3, 1. A good quick check is to check if the equation works for the other point. So if I plug in -2, 0, I can check and see that my equation does actually work. I'll get -2/5 plus 2/5, giving me 0. All right, now these are going to be a couple special types of lines here. See if you can figure out which special type of line we're going to have in each case. So here we'll have 7 minus 7 over 5 minus 3. So we're going to get 0 over 2. You never want to stop with 0 in a fraction. You have to then tell me what that means for the fraction. And so if you have no money and divide it among 2 people, they each get nothing. You can have 0 in the numerator. And so our slope here is 0. And that means that we've got a special type of line here. It's either vertical or horizontal. Well, if you take a look at what we've got a consistent y. The y coordinate is the same. So if you picture a graph where if we had all the points where y is 7 and x could be anything, so x is 1 and y is 7, x is 2 and y is 7, x is 3 and y is 7, all those points where the y coordinate is 7, you would get a horizontal line. And there's just a simple equation for that. We're just saying that it's the line with all those points with that y value. And so we just say y is 7. Now for this one, you could go through the same process. You could take the slope and a point, and you could do either one of those methods, and you would get there. But the problem we'll do in a second, you actually couldn't even do that. And really, it should be kind of a simple thing. Anytime you see the x or y isn't changing, you get a really nice, simple equation there. And again, whenever the slope is 0, you're going to get a horizontal line. I'm from Delaware. I was born and raised there for quite a while, and so I say horizontal and horrible and orange. All of my friends like to make fun of me for that. And anytime you have those lines, the equation will just be y equals a number. All right, now this one, when we try to find our slope, we're going to have the 0 in the denominator of the fraction. Well, that's not allowed. If you have $13 and try to divide it among 0 people, where does it go? It has to go somewhere. That doesn't make sense. That doesn't work. You're not allowed to divide by 0. You can't have 0 in the denominator. Some people say you can't stand on a basketball. I guess there's maybe a video of someone who did manage to do it, but most people can't stand on a basketball. So it's another way of remembering this is impossible. We call it undefined. So that's our slope. And what that means is that we could not use one of these methods for finding the equation. You can't substitute undefined into an equation. So we have to, again, just kind of look and notice what's happening here. We've got a consistent x value. The x is not changing. And so that means our equation is just going to be what that consistent x value is. This is the line that includes all the points where the x coordinate is 8. Again, if you just picture this here, you've got x is 8, y is 1, x is 8, y is 7, x is 8, y is -3. All those points where the y can be whatever you want, but the x has to stay at that same constant value. And so whenever the slope is undefined, we're going to get these vertical lines. And the equation is always going to be x equals some number. So we want to know what those kind of slopes look like. Of course, we should also know what a positive slope and a negative slope look like? It's often recommended to remember these. You could picture a person trying to climb these. So if you had a positive slope, then the person would be climbing uphill. If you have a negative slope, that's downhill. If you have a slope of 0, well, you could just walk straight across that. That's no problem. But then an undefined slope, well, that's a vertical line, because a vertical line, well, you couldn't climb up that. Unless you're Spider-Man, you're not going to be able to climb up that wall. All right, so let's go ahead and graph some lines here. So if we want to graph a line here, often the first thought that people have is to go ahead and get it in slope-intercept form. So we can isolate the y, we can subtract the 2x. We'll have 3y is negative 2x plus 12, then divide everywhere by the 3. We'll have y equals negative 2/3 x plus 4. And so then the b is our y-intercept. Make sure you start on the y-axis. And then a slope of negative 2/3. That tells us that we can go down 2 and over 3. Of course, negative 2/3, we looked at that just now as negative 2 over positive 3, so it told us to go down 2 and right 3. But you could also, of course, look at that as positive 2 over negative 3, and so you could go up 2 and left 3. Again, hopefully this is pretty basic stuff for you guys. Hopefully everybody's remembering all this and saying, why are we spending time on this in pre-calculus? But we're just taking a little bit to make sure everybody's on the same page, and then don't worry, eventually we will get to some more interesting, newer stuff for you. And at the end of the day, just make sure we had a negative slope, so make sure we've got a downhill line there. Another way to solve these, that some people do, or to graph them, is find the x and y intercepts. So you can just kind of cover up the y, because if you want the x-intercept, y is 0, so the y part of the equation goes away. And so we could have found that the x-intercept was 6, which you can kind of see what happened with our line here. And then for the y-intercept, x is 0, so the x part goes away. And so then that could have found for us that the y-intercept was 4. And so if you've got your two intercepts, you can connect them to graph your line. Now this one, make sure you remember all we need to do is we just need to graph the line. So stop for just a minute and think. Make sure you don't do too much work here. A lot of people on this are going to spend some time to write the equation. They're going to go through all the steps of one of these two methods, and they're going to find the equation. They're going to get it in slope-intercept form, and they're going to use their b and their m because they're just kind of used to going through those steps. Anytime they graph a line, they use y equals mx plus b. Well, the reason that we use b a lot of the time is that a lot of times it's in the equation. It's a convenient starting point, but you don't have to start with the y-intercept. We gave you a point right here. Let's throw this on the graph, negative 2, 3. You've already got 1 point. Well, then just go ahead and use your slope. Okay? Of course, 5 is 5 over 1. And so that would tell us to go up 5 and right 1. The thing is, that's off my graph. Well, of course, positive 5 is the same thing as negative 5 over negative 1. And so I can also go down 5 and left 1. 1, 2, 3, 4, 5, left 1. Again, at the end of the day, I just need to make sure if I've got a positive slope, I get an uphill line. All right, so we'll pause for just a minute here and let you try a problem now. Been talking for a little bit, give you a chance to try something here. Hopefully you remember parallel lines and perpendicular lines. Parallel lines have the same slope. Perpendicular lines, the slopes are opposite. That means you change the positive or the negative, and then reciprocal, of course, means you flip the fraction. So slope changes in those two different ways. So let's say we have a line that we know passes through that point and is perpendicular to this other equation. Why don't you take a minute and go ahead and find the equation of that line. And so you can go ahead and check your answer right there. You can pause the video for a second if you'd like to look through that work. You can also take a look back in Canvas, and there's a video of me explaining this if you would like to get some more explanation on that. But hopefully we're good on that problem, and then we can go ahead and move on, look at a couple word problems here. So in 2013, we've got a Manny Machado rookie card sold for $45. Believe it or not, some people actually do still collect baseball cards. It used to be a more common hobby before everybody had smartphones and video games and the internet and lots of other things to occupy their time. Back in older times, people had to find ways to occupy their time and work a little bit harder for it. So let's say his value is predicted to go up $10 each year. By the way, it's nice I can finally have a Padre in this problem. There were several years where there's no Padres players that were really noteworthy enough to include in the problem. But now we've got some good players again. So if we want to write a linear equation to model this situation, the first thing is to make sure that you realize why we actually can write a linear equation. Linear, it's got line in it. Linear means it's a line. So make sure you know why this thing actually has to be a line. And of course, it's because of this sentence right here. If the value is going up $10 each year, then that's a constant rate of change. I'll use that triangle for delta for change. And so a constant rate of change means that it does have to be linear. That means it has that constant slope. So this $10 each year, this constant rate of change, that's our slope right there. Okay, so that's the first piece of information we can use. We know that m is 10. Okay, well, so we've got the slope. Well, we also need a point. It doesn't look at first like you got a point, but you do. A point is just an ordered pair. It's any pair of information here. Well, we've got a pair of information. We've got a year and we've got a dollar value. And we are going to go ahead and call the year the x, the input. We're going to take a look at, based on what year it is, how much is the card worth. And so let's say that our point here could be 2013, comma 45. Now, you can solve the problem with this if you want. If you want to, go ahead and use whichever method you liked. Go ahead and write the equation of the line using this point and this slope. It'll work out. It'll be okay. It's just kind of big numbers. If you're using that 2013 there, a lot of times with years, we don't look at the full year, do we? I graduated from Helix in 2003. I would often just say I graduated in 03. I wouldn't often include the 2000 part. So that's a lot of times what we would do in these kind of problems. What if I switch this to just be the point 13, comma 45? That's going to make the math a lot easier for me. I just have to kind of make a mental note for myself, and not just a mental note. Usually you do actually want to write this so that everybody else knows what's going on, knows what you're talking about. Here, if we're saying this, we're saying that x is the number of years after 2000. Or sometimes you would see it written as let x equal 0 represent 2000 or something like that. So once I've got that, now I can go ahead and write the equation of my line. It'll be a little bit simpler. Numbers will be a little bit easier to work with. And you can make a different choice as well if you want. Sometimes people like to really kind of cheat and make it, you can make this the point 045 and then see if you can figure out what advantage that would give to you if you made x be the number of years after 2013. You just have to keep your variables straight. Keep straight how you define your variables, especially once we get to other parts of the problem. Make sure you know how to interpret what's going on. All right, so if we've got this information here, again, I'll use the solving for b method. You can use a different one if you'd like. So I've got y equals m times x plus b. And then I can solve for b. 45 equals 130 plus b. And so I get that b equals negative 85. And so then that means my equation of my line is y equals 10x minus 85. Okay. Again, we just need to note that x is the number of years after 2000. All right, so now we want to predict the card's value in 2025. This is where, again, we need to really keep track of, well, how do we define our variables back here? So if I define them this way, I'm not going to take 2025 and substitute it into the equation. 2025 was 25 years after 2000. And so I'm going to take 25 and substitute it in. And of course, I'm using this for x. X was representing years, and y was representing the value. So if I substitute this in here, I'll have that the value is 10 times 25 minus 85, which is 250 minus 85, which is $165. There we go. All right, so I've got another example here that I'm going to have you go ahead and give a try. This is about Mr. Babbitt. Mr. Babbitt is our math department chair, and he was my honors geometry teacher when I was at Helix as a student. He's been here for a while, and he wrote this problem early on. He teaches pre-calculus sometimes as well, and so he came up with this problem quite a while ago. And we always joke now that this year when he's planning to retire is getting closer and closer. Pretty soon, I might not be able to use this problem anymore. But he did write this problem and gives permission to use it. I'm not sharing any personal information of Mr. Babbitt that he hasn't given permission for, so don't worry about that. But why don't you go ahead and take a look at this problem and go ahead and give that problem a try there. And so here are the answers that you can take a look at. Again, you might have done the work a little bit differently. The choices I made were I did kind of the cheating way here. I made the X be years after 1991, because then this first pair of information, I had my y-intercept already. It saved me some work. And I also made the y be in thousands, just again to kind of make the numbers a little bit smaller for doing the algebra there. So you may very well have made some different choices there, so your equation might be totally different. But regardless of how you did your equation, your final answers should still match up. So make sure that your answers match up there. And again, if you want to see a video of me explaining that, you can go ahead and look back in Canvas. So that's it for our first lesson. Hopefully all this stuff was some pretty basic reminders of lines, of some stuff that you already knew. If you do have any questions at all, again, please do email me or ask me questions in our Zoom classes or come to my tutorial. Anything I can do to help you out, please just let me know.